students, welcome to Math Magnet. Math made easy. This is for all you little geniuses who need a little help with math. Remember to use this video only as a guide to help you solve your math problems after you have attempted to solve them yourselves. Let's get into today's video. Today we are going to do chapter 8, volume of solids and liquids. We'll be solving review and thinking cap questions from pupil book for grade 6B. Question number 1. Find the length of the unknown edge on each cuboid. Here in the image they have given us the length as 9 centimeters and height as 3 centimeters. They have asked us to find the breadth. They have also given the volume as 81 centimeter cube, and we know volume is length into breadth into height. So to find breadth, it will be volume by length into height. So we know all the three values. So it will be 81 divided by 9 into 3, which is equal to 3 centimeters. So the unknown edge, that is the breadth, is equal to 3 centimeters. Question B. Here again they have given us the volume of the cuboid, which is equal to 84 centimeter cube. In this image we can see that they have given 2 centimeters as the breadth and 5 centimeters as the height, and they have asked us to find the length. So we all know volume of cuboid is length into breadth into height. To find length we have to divide volume by breadth into height, which is 84 divided by 2 into 5, which is equal to 8.4 centimeters. So the unknown edge length is equal to 8.4 centimeters. Let's look at question number 2. The shaded face of each cuboid is a square. Find the length of one side of the square face. Here the volume is given as 1280 centimeter cube. Now this is the image of the cuboid. Now we know the height is 5 centimeters. They asked us to find the breadth. Okay, now they are told this one face is a square, which means the length and breadth will be measuring the same because it's a square face. Now we know the volume and we know the height. So with that we can find the area of or length into breadth. We can find by dividing volume by height. So that will be 1280 divided by 5, which is equal to 256 centimeters. Now this is basically the area of the square face, or it can also be told as length into breadth. Now that is equal to find the length of one side we'll have to find the square root of 256, because length is equal to breadth since this face is a square. So length will be square root of 256. To find the square root of 256, we'll use the prime factorization method, and using that we will take groups of 3's of repeating numbers. So this will be equal to 2. We are finding groups of 2 since we are finding the square root. So groups of 2's of 2 we'll take. So this we will get 2 into 2 into 2 into 2, which is equal to 16 centimeters. So the length of this unknown side of this face is equal to 16 centimeters. Now for the next question, similarly they have given us a cuboid and they've asked us to find the length of one side of the square face. Now in this cuboid we have a square face here, and in this square face we are asked to find the unknown length. Now they've also given us the breadth. Now we know this length into height will be the area of this square face. So let us see, the volume is given as 1573 centimeter cube. So we know volume of cuboid is length into breadth into height. So the unknown, to find the unknown height, which is length into height, will be volume by breadth. So it is 1573 divided by 13. So this will be equal to 121 centimeters. Now we need to find only the length of one edge. So basically what we have right now is the area of the square face. To find the length of one edge, we need to find the square root of 121. Since this is a square face, all the edges are equal. So we'll need to find the square root of 121. And now to find square root of 121, we will use the prime factorization method, using which we know 11 into 11 is 121. So 11 centimeters is your length of the unknown side of the square face. Question number 3. Find the length of the unknown edge in each cube. Now here this is the cube that has been given and they have asked us to find this unknown length. Now the volume that is given is 216 centimeter cube. Now we know that in a cube all edges will be measuring the same. So the length, the breadth and the height will be measuring the same. So volume of cube will be length into breadth into height and we know volume is 216. So to find one length we will need to find the cube root of 216. Now we'll do that using the prime factorization method. Now by doing prime factorization method we can say we'll take groups of threes. So now we have 2's repeating 3 times and 3 repeating 3 times. So we'll consider them as 1. So it will be 2 into 3 equal to 6 centimeters. So the length of one side or the unknown side is equal to 6 centimeters. Question number 3b. Find the length of unknown edge in each cube. Here they have given the same similar cube like this and they have asked us to find the unknown length. They have given us the volume. Now again in a cube all the edges are will measure the same. So to find the measurement of one unknown edge in a cube we will have to find the cube root of the volume. So basically volume of a cube will be length into breadth into height and volume of cube here is 2197 centimeter cube. So since all the length and the height and the breadth are equal, the length will be equal to cube root of 2197. Now this we can find out using the prime factorization method. Now over here 13 repeats 3 times and since we are finding the cube root of 2197 we will consider groups of 3's. So now we will take 13 only once. So this will be equal to 13. 2197 will be a cube root of 2197 will be 13 centimeters. So the length of the unknown edge of the cube will be equal to 13 centimeters. Question number 4. A rectangular tank with a square base of area 625 centimeters squared is 2/3 filled with water. The tank contains 15 liters of water. Find the height of the tank. Now here they have given us the base area of the cylinder or the base area of the rectangular tank. Now this base area we know is 625 centimeters square. Now this is the base area, the base of the tank. They have given the area. What is base area means? It means the length into the breadth. So we know this into this is equal to 625. They've asked us to find the height of the tank. However, they've given us the information that the tank is 2/3 filled with water and that 2/3 fill of water means it has 15 liters of water in it. Now they've asked us to find the height of the tank. To do that, first we will say 2/3 capacity of the tank is 15 liters. So what is the full capacity of the tank? That we'll have to find what is 1/3 capacity of the tank first. So 2/3 of capacity of the tank is 15 liters. So 1/3 capacity of the tank will be 15 divided by 2 which is equal to 7.5. So the full capacity of tank will be 7.5 into 3 units, correct? The whole tank is 3 units. 2 units is 15 liters. The 3 units will be 7.5 into 3 which is 22.5 liters. So the full capacity or the volume of the tank is 22.5 liters. Now this 22.5 liters can be rewritten as 2250 centimeter cube. Remember your volume and the other measurements of the edges should be in of the same unit. So here it is the base area is given as centimeter. So which means our capacity also should be considered in the form of centimeter. So it will be 2250 centimeter cube. Now we know the volume. We know the base area which is 625 centimeters square. We need to find the height of the tank. To do that, we know volume of cuboid is length into breadth into height. Now to find the height, it will be volume divided by length into breadth. So length into breadth is nothing but your base area which is equal to 625 centimeters square. So now volume of cuboid also we know. So height will be 2250 divided by 625 which is equal to 3.6 centimeters. So the unknown height of the tank is 3.6 centimeters. Question number 5. A rectangular tank measuring 25 centimeter by 16 centimeter by 20 centimeter was half filled with water after 1.5 liters of water was removed from the tank, what was the height of the new water level? Now this is the tank that they have mentioned about. They have given us the edges measurement, that is 25, 16 and 20. Now this tank is half filled with water, and after 1.5 liters of water was removed from the tank, what was the new height of the water level? Now to find what was the actual original water level, we need to first calculate what is the volume of the tank. That will give the full capacity. From that we can see what is half filled, what will be the amount of water that is half filling the tank. From that, after subtracting 1.5 liters, we can find the new height of the water level. So let's begin by solving. We'll find the capacity of the tank. That will be 25 into 16 into 20, which is 8000 centimeter cube. That is the full capacity of tank. Now half capacity of tank will be 8000 divided by 2, which is equal to 4000 centimeter cube. Now that is the amount of water that is there in the tank at first. Now amount of water removed is 1.5 liters. So 1.5 liters can be rewritten as 1500 centimeter cube. We will maintain all the units the same. So 1.5 liters can be rewritten as 1500 centimeter cube. So after that is removed, it becomes 4000 minus 1500 will be equal to 2500 centimeter cube. Now that is the new water level or the new volume of the water that is there in the tank. Now we need to find the height of this new water level. We know the base area, that is the length and breadth, will remain the same. Only the height changes, and we need to find the height. So we'll maintain the base as 25 centimeters, 16 centimeters, and we have to find the height of this new water level. We know the volume is 2500. So to find the height, we have to divide volume divided by length into breadth. So it will be 2500 divided by 25 into 16. So now that can be rewritten as, after solving, you will get it as 6.25 centimeters. So that will be the height of your water, or the new level of water. Question number 6. A rectangular tank measuring 18 cm by 9 cm by 12 cm is completely filled with water. All the water from tank is poured into an empty cubical container. The cubical container is now 1/3 filled with water. Find the length of the edge of the cubical container. Now this is the image that they have given. Here in this tank, in this rectangular tank, they are given as the measurement of the edge, and they are saying the water is completely filled in this tank, and now when you empty this water into this tank gets 1/3 only filled. This is a cubical tank. Now this is a rectangular tank. When this is poured here, this becomes only 1/3 filled, filling the cubical tank. Now they are asking us to find the length of the edge of the cubical tank. Now we know cubical container will measure, all the edges will measure the same. So now first we'll have to find out what exactly was this quantity of water. To find that, we'll have to find the full capacity of the tank, or volume of water, that is 18 into 9 into 12, which is 1944 centimeter cube. Now that is your volume of water here. Now this volume of water is poured into this, and this becomes 1/3 filled. So which means 1/3 capacity of this cubical container is 1944 centimeter cube. Now total capacity of the cubical container will be 3 times that, that is 1944 into 3, which is 5832 centimeter cube. Now that is the full volume capacity of the cubical tank. Now we need to find the edges. Now we know cubical tank, all the edges measure the same. So to find the length of one edge, we will have to find the cube root of 5 into 5, so cube root of 5832. So which means we'll have to use this prime factorization method. Here we know we'll take groups of 3's, and here we'll take 2 repeats 3 times, we'll consider it as once. This group of 3 will consider it as once, and this group of 3 will consider it as once. So it will be 2 into 3 into 3, which is equal to 18 centimeters. So the height of this cubical tank will be 18 centimeters. So which means the length of any edge of this cubical tank will be 18 centimeters. Question number 7. Which of the following is the front view of the solid below? Now this is the image of the solid given here, and here they have given us to find out the front view. Which of the front view? Now we need to identify which of these front views is the image of this block. Now clearly it is only image A is the front view of the solid given below. Question number 8. A box measuring 18 cm by 12 cm by 17 cm is packed full with 1 cm cubes. How many cubes are there in the box? This is the image that is given. They have given us the measurement of the edges of this box. They are asking if this is going to be packed with 1 cm cubes, how many cubes will be there? So basically it is going to be the volume of this box. So which is capacity of box is 18 into 12 into 17 equal to 3672 centimeter cube. So there will be 3672 cubes in this box. Question number 9. A rectangular tank measuring 12 centimeter by 9.7 centimeter by 9 centimeter contains some water as shown. Find the volume of the water in the container. Give your answer in liters correct to 1 decimal place. So over here, this is the rectangular tank and they've given us the edge measurements. Contains some water as shown. Find the volume of water in the container is what they are saying. Now to do that, first we will say height of water will be, they have given here the height, the full height of the tank is 9 centimeters and the water's height is 2 centimeters less than the actual height. So it is actually height of the water is 7 centimeters. Now with the height of the water and the length and breadth, we can find the volume of water. So height into length into breadth, which is 7 into 12 into 9.7 is 814.8 centimeter cube of water is there in this container. They've asked us to correct to 1 decimal place. It comes only to 1 decimal place. Question number 10. A cubical tank of weight 16 centimeter is 3/4 filled with water. The water is poured into an empty rectangular tank measuring 11 centimeter by 14 centimeter by 15 centimeter until it is full. How much water is left in the cubical tank? Give your answers in milliliter. Now this is the image of the two tanks. Now over here we have a cubical tank that is measuring edge measuring 16 centimeters, which means all the edges measure 16 centimeter, and this is 3/4 filled with water. Now this water is poured into this rectangular tank which measures 11 by 14 by 15 centimeter until it is completely full. Now they are asking how much is water that is left in this cubical tank. To find that, first let us find the capacity of the cubical tank, which is 16 into 16 into 16, which is 4096 centimeter cube. That is the full capacity of the cubical tank, but it is only having 3/4 of its capacity. So which means that is 3 by 4 into 4096, which is 3072 centimeter cube of water is what is there in this cubical tank. Now let us find the capacity of the rectangular tank. We have the measurement of the edges, which is 11 into 14 into 15, which is 2310 centimeter cube. Now when you pour water, the maximum water that this tank can hold is 2310. So the difference will be the water that is remaining in this cube. So 3072 minus 2310 will be equal to 762 is the water that is left in this cubical tank. Question number 11. Water leaks from a tap at the rate of 9 milliliters per minute. At this rate, how much water leaks from the tap in 5 minutes? So, amount of water that leaks in 1 minute is 9 milliliters. Amount of water that leaks in 5 minutes will be 9 into 5, which is 45 milliliters. Question number 12. An empty rectangular tank measures 80 centimeter by 50 centimeter by 45 centimeter. Water flows into the tank at the rate of 9 liters per minute. At this rate, how long will it take for the tank to be 3/4 filled with water? Now this is the measurements given for the tank, and over here we are saying water flows into the tank at the rate of 9 liters per minute. So how long will it take for filling 3/4 of the tank? Now let us first find out what is the actual capacity of the tank using the measurement of the edges. That is 80 into 50 into 45, which is 180000 centimeter cube. That is 1,80,000 centimeter cube is the actual capacity of the rectangular tank. Now for 3/4 capacity of the tank, we will have to multiply this into 3 by 4, which will become 1,35,000 centimeter cube. That will be the 3/4 capacity of the tank, which is also equal to 135 liters. Now we know that amount of time for 9 liters of water that to flow into the tank is 1 minute. We need to find how much time it will take for 135 liters. That is 135 into 1 divided by 9, which is equal to 15 minutes. So it will take 15 minutes to fill 3/4 of the tank. The next question, question number 13. A tank was 4 by 5 filled with water. 2 by 3 of the water was poured away and 620 ml of water was left in the tank. How many liters of water are needed to fill the tank completely? Now we'll have to bring these two fractions, 4 by 5 and 2 by 3 into equivalent fractions. So 4 by 5 can be rewritten as 12 by 15 and 2 by 3 can be rewritten as 10 by 15. Now we know 2 units, that is the amount of units that is remaining in the tank is 2 units, that is 620 ml. Now 1 unit will be 620 divided by 2, which is 310 ml. So to fill tank completely you need 15 units. Now for 15 units, that is 15 into 310, which is 4650 ml is the full capacity of the tank. Now they are asking to tell this in liters, so we'll have to convert this into 4650 ml. We'll have to convert it into liters, so it will become 4.650 liters of water is needed to fill the tank completely. Now let's solve some put on your thinking cap questions. Question number 1. A wooden rectangular block has a volume of 96 centimeter cube and a height of 4 centimeter. The perimeter of the base is 20 centimeter. Find the length and breadth of the block. Now this is the rectangular block that they are given. They are given us the volume, they are given us the perimeter, and they are given us the height. Now we know volume of a rectangular block is nothing but length into breadth into height. So that is length into breadth equal to volume by height. These two values we know. That is 96 by 4, which is equal to 24 centimeters. Now we know L into B, that is length into breadth, is 24 centimeters. And we also know the perimeter of the base, that is 2L plus 2B is equal to 20 centimeters. Now this can be simplified as L plus B equal to 10 centimeters. Now seeing these two equations, L into B is 24 and L plus B is 10, the only combination will be 4 and 6. So length is 4 centimeters and breadth equal to 6 centimeters. Question number 2. A barrel contains 9 liters more water than a rectangular tank with a base measuring 25 centimeters by 20 centimeters. When 3 liters of water was poured from the tank into the barrel, the volume of water in the barrel was 11 times the volume of water left in the tank. Find the new height of the water level in the tank. Now over here, let us assume let the height of the tank be equal to h. So volume of tank will be 25 into 20, that is what is the measurement given, into the unknown height h equal to 500 h centimeter cube. Now this is the volume of the tank. Now we know the barrel contains 9 liters more water than the rectangular tank, and we are pouring an additional 3 liters from the tank into the barrel. So basically it will be volume of tank plus 9 liters plus 3 liters from the tank will be the volume of the barrel, which is 500 h plus 12 L. That is 12 liters. 500 h plus 12 liters is the volume of the barrel. Now we know now both of them, it will be the volume of water in the barrel was 11 times the volume of water left in the tank. So 500 h plus 12 L, 12 liters, is equal to 11 times 500 h minus 3 liters. That is, we have removed 3 liters from the tank and poured it into the barrel. So we will have to subtract those 3 liters from 500 h. So it will become 500 h plus 12 equal to 5500 h plus minus 33. So that will be 500 h equal to 45 and h equal to 45 by 5000, which is equal to 0.09 centimeters. So the height of the water level in the tank will be 0.09 centimeters. 0.009 centimeters. Question number 3. Intern wants to make a cuboid with 12 unit cubes. How many different cuboids can be made and what are the possible edges of each cuboid? Now the different number of cuboids that can be made are 4. That is because of the different combinations of length into breadth into height, that where we can get the answer as 12. So the possible edges of each cuboid are 1 into 12 into 1, 2 into 3 into 2, 6 into 2 into 1 and 3 into 4 into 1. These are the 4 combinations in which you can have 12 unit cubes. So there are 4 different cuboids can be made. Thank you friends. Hope you found this video helpful. If yes, please do like, share with your friends and subscribe for more such useful videos. Feel free to comment your doubts down below and I shall get back to you at the earliest. See you soon with another math video. Bye.